Okay, so we are going to continue the discussion on area between two curves. Okay, so before I get into the second part of the area between two curves, I want to go over some basic knowledge that you need to know, and you actually need to know this before you go into anybody's collegiate math class. So the first thing you should know is that f of x and y are the same thing. So when we say y and f of x, we mean the same thing. And so I have y equals f of x. I can also write this function as f of x is equal to x plus 1, which would be the same as y is equal to x plus 1. And this means that y is a function of x because the value of y or f of x depends on x. All right. And then you have another function where we have f of y is equal to x. So you should know, if you don't know, the f of y is going to be equal to x. So for my equation x equals y minus 1, I could write this function as f of y is equal to y minus 1. And it means the same thing. All right. And that is just stating that x is a function of y because the value of x depends on the value of y. All right, so if you don't know these two simple concepts, you need to make sure you do know them. All right, so we're going to continue discussion on area of a region between two curves. So the two equations that I'm giving you in the example are going to be in the form of x being a function of y. So it's going to be x equal to some expression. So, okay, I'm getting ahead of myself. I want to talk about the black dots. Okay, so the black dots that you see on the graph are the points of intersection. All right, the limits of integration are determined by the points of intersection. So if you're not given limits of integration on, in your formula or when you set your integral up, if you're not given the limits, you have to find them. And the way we find the limits of integration, we set the two functions equal to each other. And wherever the intersection points are, will be our limits of integration. And then remember, whatever two values you find, the lowest one will be at the bottom of the integral, and the highest one will be at the top of the integral. All right, and the way we find area is using this equation here. So it'll be a is equal to the integral of a to b of my rightmost function, in this case is g of y, minus my leftmost function, in this case is f of y. And then we integrating with respect to y. That's the dy. So in an example, it says find the area of the region bounded by the graphs of x equals 3 minus y squared and x equals y plus 1. All right, so I graph both functions in Desmos, and this is a screenshot of the graph. So my red graph is the 3 minus y squared. My x graph is the y plus 1. And I want to find the area of the region bounded by both functions. So the only area of the region that's bounded by the function is what I have in yellow. It's bounded, and that area is bounded by the y plus 1 line, and also is bounded by the 3 minus y squared curve. All right. So from the graph, you can see what the points of intersections are. But remember, since we're integrating with respect to y, we have to look at the y values for the limits of integration. So if I'm looking at the point of intersection at the bottom, the y value for that point is at -2. If I'm looking at the other point of intersection at the top, then the y value for that intersection is 1. All right. If you were not given a graph, you can always create a sketch by using a t-table. So on my t-table, normally you would put in values for x and find y. And remember, we always use -2, -1, 0, 1, 2. And that's a good thing good points, good values to use to get a sketch. But in this case, I'm going to let my -2, -1, 0, 1, 2 be the y values. And I plugged those y values into the equation to find my x values. So if I plug in negative 2, 1, 0, 1, 2 for my y in 3 minus y squared equation, then I'm going to find my x values of negative 1, 2, 3, 2, negative 1. If I plug in negative 2, negative 1, 0, 1, 2 into my equation y plus 1 for y, then I'm going to get the x values, which are negative 1, 0, 1, 2. All right, so that's another way to sketch without, if you didn't have a calculator, or if you don't have access to Desmos, then you can always use a t-table to graph the function. And then I need to find the points of intersection. This is the algebraic way of finding the points of intersection. You can just set the two equations equal to each other. So that'd be 3 minus y squared is equal to y plus 1. And then you have to start adding and subtracting. So you can add y squared to both sides. You're going to get 3 is equal to y squared plus 1. I'm sorry, y squared plus y plus 1. And then you subtract 3 from both sides. You get 0 is equal to y squared plus y minus 2. You set you set that it was going to be equal to 0 anyway, but you have to factor that, and this factors into two binomials. One would be y plus 2, the other one is y minus 0. Then you take those factors from those binomials and set them equal to 0 to solve for y. And then I get negative 2 and 1. It should confirm what you have on the graph. So those would be your limits of integration. So to find this, it would be, again, the area is equal to the lowest number between negative 2 and 1 is negative 2. So negative 2 is going to go at the bottom, and 1 is going to go at the top. So it would be my rightmost curve minus my leftmost curve. So I have 3 minus y squared minus y plus 1. So I need to distribute the negative to y plus 1, and then combine my like terms. So I get 3 minus y squared minus y minus 1. And if I combine my like terms, 3 minus 1 is 2, then I will have negative y squared minus y plus 2 integrate with respect to dy. So if I integrate the function, I get negative y cubed over 3 minus y squared over 2 plus 2y. Excuse me. And then I'm going to integrate from negative 2 to 1. So I'm going to plug my 1 in first. I get negative 1/3 minus 1/2 plus 2. And I'm plugging in my negative 2 into the y value. And I get positive 8/3 minus 2 minus 4. And then I just need to integrate that. Not integrate, I'm sorry. I just need to simplify that. And I get my answer is 9/2. All right. So I'm giving you 5 problems to complete. Make sure you just get those done within class and upload them to Google Classroom. And then I'll probably send you another video about what's going to be on the final exam next week. And that's it.